seen the DC-DC converters, we are now going to talk about the CFC, or what we call current flow controllers. These are kind of DC-DC converters, but you will see that they are much smaller, because we are going to present which is the application of this kind of converter. Okay, first of all, I have to do a small introduction about what is a multi-terminal HVDC system. Until now, we have talked about HVDC links. An HVDC link is when we have one converter station which is connected to another converter station. But if we introduce another converter in the equation and we interconnect all the systems, we have then a multi-terminal HVDC link, which is the case here. In this scenario, for example, we are considering that system 1 is a generation node, any kind that you want, and these two systems are consuming power, and they are injecting into different networks, different AC networks. We consider that we are operating this system at nominal power, and here we have the DC cables interconnecting them. What happens if we want to increase the complexity of this DC grid? As Edu was talking in the beginning, we want to make a great DC grid in the North Sea. So we can have something like that. This is a simplest version, but what happens if we want to do a connection between them? What happens then in the current flow, in this current flow inside in the middle of the DC grid? If, for example, when we have this connection, we are not talking anymore about a multi-terminal scheme. We are talking about a meshed HVDC grid, because here we have mesh. And controlling the current flows inside this mesh is more complicated than using when dealing with a simple multi-terminal scheme. If, for example, in this case, we consider that this line is shorter than this one, the resistance here will be also lower, so the current that will circulate through that cable will be higher. And if we operate that in nominal power, we can have overloads here. So we may not be able to run this system at nominal power because of this line, because we have changed the grid. How we can solve that in order to operate this system at nominal power? Well, this is where we have the current flow controller. Current flow controller is a small device, a small power converter, that can be introduced in the middle of this DC network, this meshed HVDC network, and this current flow control is going to apply voltages on the lines. This converter is a small converter that is floating at the positive pole of the HVDC network, so it doesn't have to withstand all the voltage of the HVDC system. It's only floating at that. So this converter is applying positive and negative voltage to these lines, so it is increasing or reducing the current through that lines. This way we can operate the system by reducing this current and letting them circulate through this line. It's a way to improve the operational area of the system. Here we are showing a specific topology that Alstom Grid presented of a current flow controller. You can see this is the scheme of the converter. In this case, in this converter, what we are doing is it is a 2H bridge joined in the middle, and in the middle we have a capacitor. So this converter is extracting power from one line, and it is feeding the other line with that power using the capacitor in the middle, which is this one. And it applies positive and negative voltage into those lines, so this way it regulates the current flow inside the mesh HVDC grid. Here, just to summarize, to show the simulations of all that, of this current flow control, which is located in this meshed network. You can see the currents, line currents in blue. You can see that here we can reduce the current just from 1.1 pu to 0.8, and we are doing this by applying a voltage. Here you can see the voltage, in the pink line. It's the voltage of the CFC. And you can see that we are regulating the currents, which are the ones here, by only using that voltage, because the voltage of the terminals, which is in orange, it is constant. So we are regulating the current flow using only this device, but not the voltage of the each of the terminals.